Hey, Tim DeStasio here. It is Psychrometric Saturday once again, and we are introducing new terminology to the series, and that is apparatus dew point. Every time that we have a cooling process, whether we have a chill water coil or a direct expansion refrigerant coil, that coil has an average temperature. That coil doesn't stay one temperature consistently through the entire coil. There's an average temperature. We can calculate it by using some measurements in our supply and our return duct to figure out whether or not that coil is being effective. Say that we're working on a unit, does not matter whether it has a chill water coil or a direct expansion coil, and we've got 75-degree dry bulb and 55-degree dew point air coming in. That's our return conditions. And then leaving the unit or leaving air conditions is 55-degree dry bulb and 50 degrees dew point. That is a nice cold dry air. That's kind of what our targets, what our design supplier temperatures usually are. But we can figure out what that average coil temperature is, and that's what apparatus dew point means. So let's say, for example, a direct expansion coil. Our refrigerant comes out of our TXV or any kind of expansion valve, and it hits the coil as a liquid at 40 degrees. Now, immediately it starts absorbing heat, but there's a latent heat process there. That refrigerant does not change temperature all the way until it is completely changed state from a liquid to a vapor. At that point, now the rest of our coil starts changing temperature. We may have 50-degree, 55-degree refrigerant coming out of it. That's actually what superheat is. So the average coil temperature on this DX coil is somewhere between 40 degrees and 50 degrees. Well, what is it? Is it 42? Is it 48? Well, we wouldn't know unless we plotted it on the psychrometric chart. So how do we figure out what our apparatus dew point actually is? Well, we've got to take our process line, starting with our return air conditions, and then we take our leaving air conditions. We draw a line in between those 2 points, but we have to continue that line until it extends and hits our saturation curve. And then whatever that temperature, that dry bulb temperature is, that intersects with our saturation curve, that is our apparatus dew point, and that is our average coil temperature. So it makes sense that if we have these conditions here, and a refrigerant starts out in the coil at 40 degrees and it comes out of it at 50, but for the majority of the coil, it should be 40 degrees. And so what is our apparatus dew point, or our average coil temperature? It's going to be around 48 degrees, and that makes sense. It's a nice cold average coil temperature. Now let's take, for example, that chill water. Same conditions here. What is our apparatus dew point? Our 40-degree water immediately starts changing temperature. Where there's not a latent heat change in the chill water coil, it's all sensible. So by the time we get to the middle of the coil, it might be 45 and then 50, and by the time it leaves the coil, it might be as high as 53. Well, what is the average coil temperature? What is the apparatus dew point? Well, again, if we plot these 2 points and extend that line to the saturation curve, then we find out that our apparatus dew point is somewhere around 46 degrees, and that makes sense that it's somewhere in the middle of these numbers. So how can you use this as a technician? Well, let's say you're on a service call, you take a psychrometer, you take 2 readings, you plot your process line here, and then you extend that line all the way to the saturation curve, and you can figure out what your average coil temperature is, figure out whether your problem is in the coil or maybe it's somewhere else. I know we've covered a lot today. Thanks for sticking around. Come back next time for Psychrometric Saturday.